5. It should be page 62 and 63. Okay. Title, area of circles and sectors. Okay. Then theorem 11.9, the area of circles, and there's your formula for it. A equals pi r squared. Let me zoom in. Okay, there we go, so you can see it better. Okay, let me find something to write with. Okay, here we go. Remember, the r is the radius, so it's r squared, and pi, make sure you use actual pi button, not the 3.14. Okay, and then theorem 11.10, area of a sector is, this is the ratio of the area of the sector. Realize a sector is just a wedge, looks like a piece of pizza or a piece of pie. That right there represents a sector, by the way. Is that little section right there represents a sector. So if I was to color that in, that's what that is pertaining to, is that little wedge. Okay, so here's a proportion that you would follow, which it looks a little blurry on there. So let me try to focus it a little better. Okay, so I zoomed in a little bit. So because this formula, I always use the first one because it's a proportion, but if you want to try to choose the second one, you can as well. But this is like your other formula you had on circles, where you found the arc length. This is the same kind of a setup, except for now the one ratio here is dealing with the area, so the bottom is the area formula of pi r squared, and then the top would be the area of that sector. On this one it has APB, which is that wedge that they have there for that particular setup. Okay, so if I go to an example, on one it says they want us to know the exact area of the circle. The formula for area of a circle is pi r squared, and it does say we want nearest hundredth, and that's what we're going to do on all of these problems for this section, is just go ahead and go to the nearest hundredths, and that means 2 decimal places. If I look at my picture, I have 3.7 for the r, so that means I'm just going to replace it in my formula, pi times 3.7 squared. Well, because it says exact, that means pi is part of my answer. So my area will have something centimeters squared, and I need to know that decimal by doing 3.7 squared. Gives me 13.69. And that would be my answer. Okay, if I go to example 2, it says, okay, we want to find the radius if the area of the circle is 390 meters squared. So if I still relate back to my area formula of a circle, I'm going to plug in the 390 equals pi r squared. I'm going to get rid of pi by dividing, and realize I want to divide by actual pi and not 3.14. Gives me 124.14, and that is r squared. And now to get rid of the square, I'm going to take the square root of that number, and make sure you go ahead and have it all in your calculator so you have the remaining decimals. So for this, I'm going to do the square root, and then we'll go up and grab that number and enter. So I have 11.14 is my radius, and that is in meters for this one. Okay, example number 3 now has us use our proportion for what's given to us. It says find the area of the circle. That's my goal. And the area that they give me always pertains to the shaded section of your circle. So since this little wedge is shaded, that means this area right here is that 36.07 centimeters squared. So to set up my proportion, I'm going to have the area of the sector, which is 36.07, over the area of my circle. So I'm just going to put an A there. Is equal to the degree measure of that sector, which is 58, over the entire circle, that is 360. Alright, so if I cross multiply, I'll have 58 A's equals, and then 36.07 times 360 gives me 12985.2. And then I just want to divide that by 58. That'll tell me my area. Tells me this is 223.88 centimeters squared is the area of the circle. Okay, and that was part A. Part B says, okay, we want to find the radius of the circle now. So if I'm looking at my picture, if I set up my proportion, the shaded area is still the sector, so that's 84.14. Now I want the radius, so instead of putting an A here, I'm going to actually put the formula so it breaks it down a little more. And remember, it's out of 360, but this 161 is the degree of the unshaded, so I need to know what the other side is. So to find that, remember, all the way around is 360. I'm going to subtract the 161, and that gives me 199. So that means this degree over here is 199 degrees. That is what I place on top. Oops. On top of my ratio, because I want this ratio degree to be the shaded side of my circle. Now I'm ready to cross multiply again in that particular way. 84.14 times 360 gives me 30290.4. And in this other direction, I'm going to put the 199 pi in r squared. Just put it in front. Now if you want to actually calculate and get a long decimal, that's okay. Because now at this point, I'm going to divide by 199 pi. And divide over here by 199 pi. And when I put this in my calculator, the bottom has to be in parentheses so it'll do this calculation. So I have that value. Now if you make it a stacked fraction, you don't have to worry about parentheses. So this gives me roughly 48.4509, on and on. I'm going to leave that in my calculator. Because that's gone, that means I have r squared equals this. So to get rid of that r, or get rid of the square, I have to take the square root of that number, whatever that is. So if I go to my calculator, I'm going to do the square root, and then I'm going to go up and grab that number and enter. That way I have the number in my calculator, and that says that the radius is 6.96, and my units on this is meters, and that would be your answer. Okay, if this is making sense to you, draw yourself a smiley face. If it's not and you may need some more directions, give me a sad face here so I can know what to do with you whenever I check your notes tomorrow. Thank you. Bye-bye.